Hello, and welcome to RootBin Studio. In this tutorial, I will show you a fun way to implement 2D roguelike room generation in Unity. Each room can have a door at the top, bottom, left, or right wall, and it will be randomly generated. So starting with a brand new Unity project, the first thing to do is to create our room prefab. Create a new empty game object called room. Then create another empty game object inside of it called walls, and another one called doors. Inside of the walls game object, create a new 2D square and call it top wall. Make sure to reset the position to 0, 0, 0 and do the same for the room parent object. Now on the top wall object, we set the scale X value to 18 and the position Y to 4.5. Duplicate it to create the bottom wall and change the Y position to negative 4.5. Now create a new 2D square and call it left wall. Set the scale Y to 8.5 and the position X to negative 8.5. Now duplicate it to make the right wall and change the X position to positive 8.5. Now it's time to create the doors. Inside of the doors game object, create a new square and call it left door. Set the color to black and the X position to negative 8.5. Then set the scale Y to 3. Duplicate it to make the right door and change the position X to positive 8.5. Then create a new square and call it top door. Set the scale X to 3 and position Y to 4.5. Duplicate it to make the bottom door and set its Y value to negative 4.5. Now select all the doors and set the order in layer to 1 in the sprite renderer to make sure they get rendered in front of the walls. I will change the color of the main camera to black. Inactivate all door game objects. We will randomly activate them using a C# script soon. Make sure we can open and close the doors in every direction. Create a new folder called prefabs and drag and drop the room into it to make a prefab out of it. Then we can remove it from the scene. Create a new empty game object called RoomManager. Then create a new folder called scripts. Create a new C# script called RoomManager. Create another C# script called room. Drag and drop the RoomManager script into the RoomManager object. Then drag the room script onto the room prefab. And now it's finally time for some coding. Let's start with the room script. Remove the start and update method and make a new serialized field game object top door. Then copy and paste it 4 times and change the name so we have top door, bottom door, left door, and right door. Create a new property of type vector2int and call it RoomIndex. Then create a new void method called openDoor that takes a vector2int direction parameter. Then we check if direction is up, down, left, or right, and activate the door with the setActive method, depending on the direction we passed into it. If direction equals to vector2int.up, top door setActive true. Copy and paste it to do the same for bottom, left, and right. Now go back to Unity and open the RoomManager script. Remove the start and update functions and make a new serialized field game object room prefab. Create a new int room width and set it to 20, and a new int room height and set it to 12. This will be the size of each room. Then create a new field called grid size X and set it to 10, and a new field grid size Y and set it to 10 as well. This will be the size of our grid. All rooms will be spawned inside of this grid. Create a new private list of type game object called RoomObjects. All rooms will be stored in this list. Then create a new 2-dimensional private int array called RoomGrid. All new rooms will be spawned inside of this grid. Create a new private integer called RoomCount. And 2 new serialized fields at the top, private integers called maxRooms and minRooms. Set it to 15 and 7. Or 10 or whatever you want, depending on how many rooms you want to be spawned. Then create a start function and set RoomGrid equals to a new int array grid size X and grid size Y. Create a new method with return type vector2int and call it getPosition from gridIndex. It takes a vector2int gridIndex parameter. Inside it, we set gridX equals to gridIndex.x and gridY equals to gridIndex.y. Then we return a new vector2int where the first parameter is room width times gridX minus grid size X divided by 2, and the second parameter is room height times grid Y minus grid size Y divided by 2. This calculation gives us the position of the room based on the grid index. And now, just for debugging purposes, we want to be able to see the grid in the editor. So we will use the onDrawGizmos method. Create a new private void onDrawGizmos. Give it a color by typing color equals new color 0110.05. Gizmo.color equals gizmocolor. Then we make a nested for loop for the X and Y grid sizes. First, we check if X is less than grid size X, and inside of that loop, we make a loop that checks if Y is less than grid size Y. Then we make a vector2 int position and set it to get position from grid index and pass it a new vector2 int of x and y. Make sure you set it to vector2 int and not vector3. We might change this later. Then we say gizmos.drawWireCube and pass it the position and a new vector3 of room width and room height, and set its z value to 1. Now, as we can see, drawWireCube requires a vector 3, so instead of position, we give it a new vector 3 of position x and position y. Now, back in the editor, if we zoom out, we should be able to see the grid now. Well done! Get a cup of coffee before we go back into the RoomManager script. So back in the RoomManager, we want to add a new field, private queue, vector2 int called roomQueue, and set it to a new queue of type vector2 int. This will be the queue for our room generation, so all rooms that are about to be created will be added to this queue. In the start function, make sure it is set to a new queue of vector2 int. Now below the start, we want to create a new method called startRoomGenerationFromRoom that takes a vector2 int room index. This method will start the generation of rooms, and it will begin with the room index we pass it. First, we use the room queue and enqueue the room index. Then we make variable x and set it to room index x, and y to set to room index.y. Then we set the xy element in the room grid array to 1 and increase the room count with room count ++. Then we make a var initial room and instantiate a room prefab at position get position from grid index, passing room index, and set the quaternion identity since we want no rotation. As we can see now, we messed up a little earlier. We need this position to be a vector3 instead of vector2 int. So we go back to the getPosition from grid index method and change the type to vector3. Also change the return to vector3, and inside of onDrawGizmos we set position back to vector3, and then just pass the position into the drawWireCube. Now in the start room generation from room method, we set the name of the initial room to room-room count. Then we grab the room component using getComponent of type room and set the room index to room index. Finally, we add initial room to room objects. Now in the start method, we create the initial room index by making a new vector2 int with the values grid size x divided by 2 and set y to grid size y divided by 2. This makes us start generation in the middle of the grid. Start room generation from room initial room index. Now back in the Unity editor, we need to assign the room prefab into the room prefab field in the RoomManager game object. And now if we press play, we can see that the initial room is instantiated in the middle of the grid. We can also see that we need to assign the doors to the door field. So open the room prefab and assign each door to the matching door field. Now in the RoomManager script, we need a method to generate more rooms. For now, it will look almost like the previous method we created to make the initial room. Create a new private bool try generate room with a vector2int parameter named RoomIndex. Int x equals RoomIndex.x and int y equals RoomIndex.y. RoomQ.enq RoomIndex. RoomGrid xy equals 1. RoomCount plus plus. var new room equals instantiate room prefab. Get position from grid index room index. Quaternion identity. New room get component room. Room index equals room index. New room dot name equals room dash room count. Room objects dot add new room. Return true. This will return true if we successfully created a room, and false if we failed to create a room. Now create an update method and say if roomQ.count is greater than 0 and room count is less than max rooms and generation is not complete. Then we need to create the private bool generation, complete, and set it to false. Inside our if statement in the update method, we create a new vector2int named RoomIndex and set it to roomQ.dequeue. Set int gridx to RoomIndex.x and int gridY to RoomIndex.y. Then we call the try generate room method 4 times and pass it gridx and gridY. This will be for all 4 directions, top, bottom, left, and right. So for the first one, we use gridx minus 1 and gridY. For the second, we use gridx plus 1, gridY. For the third, we use gridx and gridY plus 1. And the fourth, we say gridx and gridY minus 1. Then we add an else if exclamation mark generation complete to see if the generation is not complete yet. If so, we set the generation complete to true and we can log that generation successfully completed. Now, if we go back to Unity Editor and press play, we can see that our room generation works. We just need to add some randomness to make it not look the same every time. So, inside of our try_generate_room method, below the declarations of x and y index, we check if room count is greater than or equals to max rooms. If so, return false. Then we can also check if random.value is less than 0.5, and room index is not equals to vector 2 into 0, we return false. If we try this in the Unity editor now, we can see that we get random generations every time. A nice tip to be able to go into play mode quicker is to go to Project Settings in Unity, and then Editor, and scroll down to Enter Play Mode Settings and check the box for Enter Play Mode options. But as we can see, the rooms has no doors open and can all be spawned right next to each other. We will fix this. Now, to add the door logic, we first need to figure out if a room has adjacent rooms. So create a new private int count adjacent rooms, vector2 int room index, int x equals room index x, int y equals room index dot y, int count equals 0. And now we will calculate all neighboring rooms using the room grid array. So first we check if x is greater than 0 and room grid x minus 1 comma y is not equals to 0, count plus plus. This means we have a room neighbor to the left. If x is less than grid size x minus 1 and room grid x plus 1 comma y is not equals to 0, count plus plus. Then we have a neighbor to the right. If y is greater than 0 and room grid x comma y minus 1 is not equals to 0, count plus plus. Then we have a neighbor below. And if y is less than grid size y minus 1 and room grid x comma y plus 1 is not equals to 0, count plus plus again. That's our final neighbor check, meaning we have a neighbor to the top. Return count. Now, as we enter the try_generate_room method, we assess whether the count of adjacent rooms for room index exceeds 1. If it does, we return false. This approach imbues our room generation process with a snake-like quality, preventing rooms from clustering too closely. Beautiful, isn't it? We can clearly see the difference, and you can remove this code if you prefer to have a lot of rooms clustered together. Now it's time for the open doors method that we've all been waiting for. Create a new void open doors that takes a game object room and int x and int y. Type room, new room script equals room.getComponentRoom. Then we will do the same for all neighbors. We will create a new method called getRoomScriptAt that takes a vector2 int index so that we can get the room script based on the grid position. Room, get room script at vector2 int index. Game object room object equals room objects dot find r arrow function r dot get component room dot room index equals index. If room object is not equals to null, we return room object get component room. Otherwise, we return null. Now we can use the method getRoomScriptAt for each neighbor. For the left room script, we pass x minus 1, comma y. For the right room script, we pass x plus 1, comma y. For the top room script, we pass x, comma y plus 1, and for the bottom room script, we pass x, comma y minus 1. Now we determine which doors to open based on the neighbors we got. If x is greater than 0 and room grid x minus 1 comma y is not equals to 0, we have a neighbor to left. I guess all this might be even harder to follow if I read it out loud, so I suggest you just try to follow along and pause the video to see that you got it correct. So pause the video and make sure you got it all right. I will have a link to the code in GitHub in the description. If we have a neighbor to the left, we want to open door to the right on the left room script. And we also want on the new room script to open the door to the left. So two adjacent rooms will always have a door connecting to the other one. So you can go back and forth between two adjacent rooms. If we have a neighbor to the right, we want the new room script to open door to the right and the right room script to open door to the left. If we have a neighbor below, we want the new room script to open door in the direction down and the bottom room script in the direction up. And finally, if we have a neighbor above, we want the new room script to open door in the direction up and the bottom room script in the direction down. Then if we try this out, we understand that we are not calling the open doors method yet. So go into the try generate room method, and after a new room is instantiated, call open doors and pass new room and X and Y. Now when our rooms are generated, we can see that all doors are activated successfully. Every door leads to another room, and all rooms have a door connected to their adjacent rooms. What we can do now is to create a method to try to generate all rooms again if we somehow failed to get the correct amount of rooms between min rooms and max rooms. Create a new private void called regenerate rooms. We clear all data from the previous try of generating rooms by calling roomObjects.forH, destroy, roomObjects.clear. Room grid equals new int array of grid size X and grid size Y. RoomQ.clear to clear the room queue and set room count to 0. Set generation complete to false. Make a new initial room index, vector2 int with values grid size X divided by 2 and grid size Y divided by 2. Then start room generation from room and pass the initial room index. Now in the update function, we add an else if room count is less than min rooms, and if so, we try again to generate all rooms. If we try this out, we can see that it will keep trying until we have a correct amount of rooms now, so it's not possible to have fewer rooms than the min rooms that we have set. If we get this error, index was outside the bounds of the array, we can just simply increase the grid size. I will make the fields into serialized fields so I can change it in the inspector. And that's it for this tutorial. If you liked it and want to see how to make a roguelike or roguelite game out of this, make sure you leave a like and a comment. And make sure you subscribe to the channel if you don't want to miss the next tutorial. See you in the next one.